This is lesson 4 in topic 3 of module 1. This is a 2-day lesson. Let's start with day 1, warm up. What information can you gain from each representation for any given scenario? A table of values listing data points. Well, we can take those data points and we can create a scatter plot. Number 2, a scatter plot composed of the original data values. We can use this to form a regression line. A regression equation can be used to make predictions. A table of values listing the residuals, you can create a residual plot. A residual plot can be used to determine whether there is a model that can be better fit than a linear model. A residual plot can be used to determine whether there is a model that can be a better fit than a linear model. Here's our learning goals for this lesson. You have learned about correlation coefficients and residual plots. How can you use these measures to determine if a linear model is a good fit for the data set? Let's explore. Getting started. What aren't you telling me? For each data set, determine the regression equation and the value of R, our correlation coefficient. Number 2, calculate the average of X values in each data set, then calculate the average Y values of each data set. All right, so let's take set number 1. Take your graphing calculator and let's find our regression line. Turn your calculator on. Mine might need some batteries. Hold on. Okay, now we're back with fresh batteries. Remember to make sure that your diagnostic is on before you start entering your statistics. So we'll hit second catalog, and we'll go down to diagnostic. There you are, turn you on. Okay, now we'll go and edit our statistic points. We can scroll up and clear the list. Hit clear list, L1. Hit clear list, L2. Go back to statistics, edit. Here's the list we're going to enter for set 1, 10, 8, 13, 9, 11, 14, 6, 4, 12, 7, and 5. List 2, 8.04, 6.95, 7.58, 8.81, 8.83, 9.96, 7.24, 4.26, 10.84, 4.82, 5.68. And we'll go back to statistics and calculate the linear regression for L1 and L2. All right, so let's take a close look at this data. We've got a linear regression line for set A, and that would be y equals 0.5x plus 3 based on the data. My R is 0.816. Not very strong, is it? Continue this process for the rest of the data sets. So hopefully you've taken some time to go through this. If you need to pause the video, do so, and enter practice set 2, set 3, and set 4. And once you've done that, you're going to notice you're going to have the same linear regression line and the same correlation coefficient as 0.816. So it's not very strong. And if you look at your R squared, it's weak as well. Remember, we want that close to a positive 1 or close to negative 1. Number 2, it says calculate the average of the x values in each data set, then calculate the average of the y's in each data set. So let's just take set 1 and let's just take the average. So I'm going to take 10 plus 8 plus 13 plus 9 plus 11 plus 14 plus 6 plus 4 plus 12 plus 7 plus 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So 99 divided by 11 is 9. So my average for my x's is 9. And then let's calculate the average for the y's. Here I've got 8.04 plus 6.95 plus 7.56 plus 8.81 plus 8.33 plus 9.96 plus 7.24 plus 4.26 plus 10.84 plus 4.82 plus 5.68. And that's also 11 pieces of data. So that gives me about 7.5. Okay, so the average for your x values in set 1 is 9, and the average for your y values is 7.5. So let's take a look and see what all that means. Number 3, what does all this data tell you about the similarities between the 4 data sets? What does the data tell you about the differences between the 4 data sets? Explain your reasoning. Well, the data sets have the same summary statistics, but the actual data points are not the same. So the data sets have the same summary, the data sets have the same summary statistics, same linear regression, same average of x values, same average of y values, but the actual data points are not the same. Number 4, we're going to graph each data set. Construct a scatter plot for each of the data sets. What does each scatter plot tell you about the data set? So let's plot those points from set 1. Set 1 had 10 and 8.04, 8 and 6.95, so here I have plotted the points and the line of regression. If you take your calculator and look at what you have graphed for data set 1 and hit zoom stat, except I have the wrong line in there, so let's fix that. 0.5 x plus 3. There we go. So it should look something like that. Now let's graph data set 2. Data set 2 looks a little different. Here's the visual that you should get on your graphing calculator. Remember that you want to hit zoom stat, which is number 9. Also remember you want to enter your linear regression line, 0.5x plus 3. Your plot needs to be on. Your data points for your second table needed to be entered. So you notice it looks like a curve. Looks like a curve. It doesn't look linear. Let's look at data set 3. Here's data set 3, graphed on your graphing calculator and on your graph in your book. Very interesting graph here. We got a point to kind of almost like an outlier right here. Let's graph data set 4. Data set 4 looks like this, graphed on your graph in your book and on your graphing calculator. So it looks like we have one set that appears to be linear, and the rest of them seem to have different modules. In data set 1, it seems to be a linear model is appropriate. In data set 2, based on the shape of the data, a linear model does not seem appropriate. Data set 3, based on the shape of the data, a linear model seems appropriate. So it seems appropriate here in data set 1, and it seems appropriate in data set 3. Data set 4, based on the shape of the data, a linear model does not seem appropriate. So remember, they showed the same linear regression, but it didn't work for all 4 graphs. Let's keep exploring. Activity 4.1, determining the best model. The table shows the number of CDs sold in the United States since 2000. Sandy wants to know the relationship between the time since 2000 and the number of CDs sold can be best modeled with a linear function. Number 1, construct a scatter plot of the data on the coordinate plane shown. 0, 13,000 and 15, 13,215. So that's our y-intercept. That's where it crosses the y-axis. 2 and 12,044. Let's continue to plot these points. Here we've plotted these points on the graph. Number 2, based on the shape of the scatter plot, do you think a linear module is a good fit for the data? Yes, the data seems to form a decreasing line Is it a good fit? No, the data seem to form a curve. So, yes, a linear module would work, but is it a good fit for the data? Interesting question. So yes, the data seems to form a decreasing line. So these are two sample answers that you might have come up with. You could have thought, yes, the data seems to form a decreasing line, or maybe you thought, no, I'm seeing that it's forming a curve and it just doesn't work. Let's keep exploring. Number 3, calculate the line of best fit for the data. Write a function to represent the number of CDs given the time since 2000. Interpret the line of best fit in terms of this problem situation. Then graph the line of best fit on the same coordinate plane as the scatter plot. I'm going to take some notebook paper to show you how to calculate the line of best fit. By hand, you can do this in the calculator and form the regression line. We're going to use y equals mx plus b. Hopefully you've done some practice through Khan Academy on this. We know what our b is. When our x is 0, my b is my y-intercept. And that was 13,215. So I know what my y-intercept is. I don't know what my slope is. And that's what we're going to calculate. Pick out 2 points in your data set. We can use 0, 13,215. And I'm going to pick out another point from the data set. Let's say I pick out 10 and 3,389. This is my first x, this is my first y, this is my second x, this is my second y. I'm going to use my slope formula. Second y minus first y over second x minus first x. This is my slope formula. So I've got 3,389 minus 13,215 all over 10 minus 0. 3,389 minus 13,215 gives me a negative 9,826 divided by 10, negative 982.6 would be my slope. So my equation would be y equals negative 982.6 x plus 13,215. If you used a different point, you're going to have a different slope here. Hopefully it's close. You may get negative 856, but it's still showing that it's a negative line. You might get something different, but it should be close to this. Now we're going to compute and interpret the correlation coefficient. So here we're going to plug it into our calculator. Edit. 0, enter 2, enter 4, enter 6, enter 8, 10, 12, 14, 16. 13,215, 12,044, 11,447, 9,373, 5,471, 3,389, 2,486, 1,800. let's calculate the linear regression. Strong numbers here for r squared and r. And here when we calculate the linear regression, we've got the same y-intercept, but a little bit different of a slope, like I was saying. So the correlation coefficient is your r, and your r is negative 0.9745. So that's a very strong decreasing correlation. Number 5. Write that down before we move on. Strong negative linear correlation. Based on the correlation coefficient, do you think a linear model is a good fit for the data? Well, yes, I see that my r squared is close to 1. I see that my r is close to negative 1. I would say that this is a good fit. Seems like it's a good fit. But we'll keep exploring. If we look back at the data, I notice that they're a little low and then they increase. Or, I'm sorry, they start out not decreasing that much and then they start drastically decreasing. Number 6, use the line of best fit to predict the number of CDs sold each year. Okay, so we have our actual data. What's happened since 2002? So now we're going to make predictions and see if they line up. So 2007, here's 2000, here's 2002, 2004, 2006, 2008. So we're going to enter 7 in for our data set. So I'm going to take my linear regression that they gave us,